You're a software engineer. Then you've been told to control dependencies. Windows no longer has blue screens of death because the OS stability no longer depends on the application stability. And we talk about the Ariane 5 disaster a lot. And one reason that this crash is possible is a failure to remove the dependence of the rocket safety on this component that wasn't even being used. And of course, this discussion comes up all the time with design patterns. Over the next minutes, I'm going to convince you that a big reason why controlling dependencies is hard, as evidenced by the Ariane 5, is that we don't actually know what this means. And we've been talking about dependence for decades. It occurs all over the place in our books. Robert Martin used it over 100 times in clean code. Martin Fowler, 40 in refactoring. And it's just a norm to launch these discussions without definition. Neither of these books define dependence. And yet, when you look at what they say under a microscope, it's often contradictory or in tension. So, it's a running example. I'm going to use, I have an iPhone app, and it uses an analytics framework, but it doesn't use it directly. I've interposed an analytics abstraction layer. And now my question is, does the app depend on the analytics framework? And if I look to our books for advice, then Martin Fowler seems to think that having this interposed delegator removes the dependence. And Robert Martin says that if something logical depends on the implementation, like something about its behavior or something important depends on my choice in the analytics framework, but I've hidden which analytics framework I'm using something like an abstract delegate factory, then that's bad. Something physical should too. There should be something in the program text that actually references the choice of which analytics framework I'm using. So you put these together, and these guys are like best buddies, basically. Then what I'm getting is that it does remove the dependence, and this is a bad thing. So you didn't have to look very hard to find something in tension. And to really draw out the confusion and mist around the idea of dependence, we prepared 9 dependency puzzles, of which I'll be presenting 3 right now. The framework puzzle. We like to say that if A calls B, then A depends on B. But now suppose A is actually a round-robin scheduler, and so it's calling all kinds of tasks. So does this mean it depends on each of the tasks? The crash puzzle. And we like to think that A does not depend on B if a change to B cannot break A. But I can just make B crash, then everything crashes, then everything breaks. So does everything depend on every other module? The fallback puzzle. I have a program and it's using payments processor B. But it doesn't matter if B fails to process the payments, because in that case, we'll just try payments processor C. So does this mean that it does or does not depend on payment processor B? What if it actually used payment processor B when I ran it? Did it not depend on it? In this talk, we're going to clear up this confusion and reach a formal definition of dependence. As our first step, we can actually see that there's not just one question of dependence, it's actually many. So I can give many answers to the question of the analytics framework. Does it depend? No, I can build them separately. But yes, a crash in the framework will be a crash in the app. But no, I can just use a different framework without changing the code, and I'll still have working analytics, except it's an open secret that no 2 analytics frameworks give the exact same numbers. So I might get more statistical accuracy if I use a different one. And also, if I'm doing security audits, then any security vulnerabilities in the framework will be security vulnerabilities of the app as well. And you might notice that these are actually answer different questions. We can parameterize out the many questions of dependence by 3 factors. Let's look at each. So consider this paragraph. The moment you import a new package into your project, it becomes a dependency. And the project does not depend on it until it's used. And the dependency is Google Analytics, but I can just switch out some other analytics framework without any changes, then it is not depending on Google Analytics. So these aren't just different questions. These are actually different models of execution, different meanings of what it means to run the app. And we saw 3 of them in play. There's a static semantics, whether a program is well formed. And these correspond to build dependencies. There's actually running the app, dynamic semantics. These correspond to things like crashing and runtime behavior at exact values. And then there is the modular correctness, what I can say about each component, what guarantees it makes. So this is the program logic, and it tends to correspond to functional requirements, which I think are the most interesting kind of dependence. So now we can already start to categorize these questions accordingly. Built separately, static semantics. Crashing, dynamic semantics. Can swap it out and I still have working analytics, whatever working analytics means, program logic. But stuff about statistical accuracy and security also sounds like program logic. So it's not enough. But you might notice from those last 3 about whether it's secure and whether it has working analytics. Those are actually different properties. So you should never ask, does module A depend on a module B? But rather ask, does some property phi of A depend on B? And now we can classify these better by looking at the property. So yeah, the well-formedness property does not depend, does depend in runtime behavior, does not depend in correctness, does depend to performance, and does depend in security. But there's a tension here. I'm saying that whether it works does not depend, except that I can hack into some versions and not others and make them not work. So maybe correctness does depend. But still, we're on our way to resolving some of these puzzles. For the framework puzzle, we see that many runtime properties, like how long it takes, what happens when, what values appear, do depend on each of the tasks, but the correctness does not, except one of them might hog the scheduler and never terminate if it's not a preemptive scheduler, and I've actually seen examples in other dependence papers of this exact thing. So there's one more factor, permitted changes. An operational definition of dependence, a defining property we'd like to have, is that if A does not depend on B, then no change to B can affect A. But there are some caveats. What if that change to B mucks with the internal variables of A? What if B crashes, as we've said? So we're kind of left with this tautological definition. If A does not depend on B, then no change to B can affect A unless that change introduces a dependence. And it's easy to say, well, we should just exclude these kinds of changes. But sometimes, like when we're talking about security dependence, we really do want to include them. And for an instantiation of this, here's the analytics framework. And we're trying to determine whether the logged in event being recorded depends on this record app open call. So we can look into the assumptions and guarantees of this method, and we can ask, so is there any change to the spec of this function that affects a property? And of course there is. We can say, oh, in addition to logging the app open event, it also destroys everything else, and then that breaks the property. But if we allow ourselves to impose an additional constraint on the permitted changes to the spec, this we call a super spec, then it changes the story. So here we impose a frame condition. We say, however you break the record app open function, it is not permissible to make it affect the status of the analytics framework. And now, no dependence of the logged in event being recorded on this function. And this finishes a couple of the puzzles. So if we just rule out hogging the scheduler, then there's no correct dependence from the scheduler to each of the tasks. And we can similarly rule out crashing changes, and now not everything depends on everything else in this context. But this still doesn't tell us how to address The fallback puzzle. Instantiation of this. The analytics frameworks try to send data to the US server, but if it fails, it will send to the EU server instead. So I go and actually run it, and it sends to the US server. So did its succeeding depend on the US server working? And an insight is that this question is actually isomorphic to a physical question about sprinklers. It rains, the grass is wet, but if it didn't rain, the sprinkler would have come on. So did the grass being wet depend on the rain? And what we're actually discovering is that dependence is the same thing as causation. And in fact, secrets. All the puzzles that we presented are isomorphic to some question about causation in the physical world. The round-robin scheduler, depending on task, is like, I'm stacking boxes. Does my ability to stack these boxes depend on what's in them? Well, the weight does. Everything depends on something that may crash. It's like saying that you just sitting there watching this recording is caused by my decision to not cut your electricity. I affect everything you do. And of course, the fallback puzzle is isomorphic to the sprinkler. And this insight is great news because there's been a lot of research into causality, and we can just look up some of what they say. Causal inference researchers work in these kind of causal graphs, which are basically straight line programs. So here's a causal graph for the sprinkler. The rain was true, the sprinkler is the opposite of rain, it's false, and the grass is wet if either the rain happened or the sprinkler came on. And now we can ask, did the rain cause the grass to be wet? Which is like asking, did the data setting successfully depend on the US server being up? And a naive answer is, well, what if just look at the counterfactual where it didn't rain? And that doesn't work because if it didn't rain, then the sprinkler would come on and it's still wet. So there's a naive definition of causation, which is called but-for causation, which is we say A is an actual cause of B if had something else happened, B would not have happened. And that did not work here. And there have been a number of definitions proposed to work around this, and one that I like a lot is the Halpern 2015 definition, which says that we're also allowed to keep some things the same. I was looking at this counterfactual world where the rain did not come on. And of course, the real definition has a lot more Greek letters, but here's how it plays out in this example. So we say, well, what if the rain didn't come on, and we keep the sprinkler off because in the actual execution, the sprinkler was off, then the grass would not be wet. And so from this definition, the rain happening is an actual cause of the grass being wet. And so by the exact same reasoning, the success of sending data did depend on the US server. It was caused by. And generalizing to the third puzzle, while the ability of the app to process payments might not depend on the stability of processor B alone, in a specific execution where it actually uses processor B, it does. And that concludes our demystification. And now we can reconcile some of this contradictory advice. So Martin Fowler is talking about how inserting your abstract delegate factory removes the build dependence. And Robert Martin seems to be saying that if a correctness property depends on which analytics framework you're using, then you shouldn't be using this abstract delegate factory. You should actually have direct reference textually, make the well-formedness depend. And now we can see that these pieces of advice are actually not in contradiction, that it can still be good to insert this analytics abstraction framework when the choice of if analytics framework does not matter, when the correctness property is not affected by the choice. But when you are relying on a single choice, then not such a good idea. We do a lot more than this in the paper. We have a lot of discussion about how to lift definitions of causality from these straight line program causal graphs into arbitrary programs. we define all this formally and can, from a single formal definition, recover several intuitive notions of dependence. We talk a bit about what to do about things like timing, dependencies, visual constraints, and we also have some insights into the relationship between dependence and coupling. So in conclusion, never ask if A depends on B. You have to specify this choice of semantics, what kind of execution model, what property, and what changes are under consideration. And this, we have insights that dependence, same thing as causation, lets us figure out these questions about fallback and translate a lot of research over from the causal inference worlds. And in the future, we hope this work can help people apply our ideas about dependence to specific domains, create specific definitions of dependence, some of which can be automatically checked by tools, and overall give developers clarity on how to control dependencies.